Before we get started, just want to take a quick survey. How many folks are currently using React? A few people, okay. So this is a basic session on React. We're not going to go into too many of the low-level details. Again, it's a beginner-level session, so just so you know, we're not going to talk too much about advanced stuff, even though towards the end we'll discuss Flux, which is an architecture that you can build on top of React. And for folks who aren't using React, how many folks are using Angular? Out of curiosity, wow, that's a large number of folks. So React is very different than Angular in terms of the way that it works. One of the main differences is that Angular uses very heavy concept of two-way data binding and uses directives and other things like that, which are advanced concepts in the web world. React is a framework that it's actually much simpler than something like Angular, as we'll see. And that's one of the reasons I like it. The framework itself is actually not very big in terms of all the different concepts that you have to learn, but it's still very usable and it's very simple. Okay? So the main thing with React in terms of how it differs from other frameworks is that at this point it's a UI-only library. So it doesn't have anything that it dictates in terms of the controller or specifically the model. That's stuff that you have to bring into it, and indeed, people have used React inside of Angular. People use Backbone with React and other frameworks as well. It was developed at Facebook, and it is open source. It currently powers Instagram.com, but there are lots of big websites already using React, and lots of developers using it. There's a huge amount of mindshare, especially in the past 6 to 9 months. There are quite a few people who've come to learn React and like it a lot, sort of like I do. Right? So let's talk about some basic concepts first to give you an idea of how React differs from some of the other frameworks and how some of the frameworks are actually borrowing the ideas that are in React and putting it into their own framework. So the first thing we want to talk about is this concept of isomorphic. Now, isomorphic means that your JavaScript code can run either on the browser or on the server. Okay? Obviously, you have to have a JavaScript runtime on the server to be able to do this, and what people typically use to run React on the server is they will use something like Node.js. People have also successfully run server-side React code using Nashorn on the JVM. Right? How many people are familiar with Nashorn? A few people? Okay. So Nashorn is the next generation JavaScript engine for the JVM. And it has some limitations. For example, you know there are lots and lots of Node libraries that are available out there. Unfortunately, you cannot run most Node libraries inside of the JVM at this point. There are a couple of projects where people are trying to build essentially more compatibility between Node libraries and running those libraries inside of the JVM. But typically, again, people run server-side React.js with Node.js. And the way that this looks conceptually is that your code sits squarely in the middle. You have the flexibility when you're writing a React application to either run your code on the server or run it on the browser. So you can package up your entire React application, push it up to the web browser, let it run everything, let it do all the component rendering and things like that. Or you could also say, you know what, I prefer to run this block of code on the server, so let's run it on the server. The reasons why you might do that is it might be something that's data intensive, so it may be going and making a database call and getting a lot of things that it needs to construct, let's say a search box or a list of issues in a tracking system or something like that. So you may want to render that component on the server so it's faster and render it on the server, you ship that up to the browser, React will just plug in that HTML that you've generated on the server, and it's very, very fast. So it allows for low-level performance management that you typically cannot do in other frameworks. Right, so it also gives you a huge amount of flexibility in how you compose your application. Right? We'll get into that when we get some of the demos, but that's not the main reason that React is fast. Obviously, rendering on the server, and when I say rendering, that is taking a React component and producing the HTML and CSS that you need to be able to show it in the browser. But that's not the main reason why React is fast. Okay, and this concept was around before, but React made this mainstream. The main reason why React is fast is because it has this concept of a virtual DOM. And what the virtual DOM basically is, it is a snapshot in JavaScript objects of the native DOM. So everyone is familiar with what the DOM is. The DOM is essentially a tree starting with the window object, and as you add elements into a web page, you had a body and then have an H1 and div tags and other things like that. Those all become native DOM elements that are actually shown in the browser. So what React does is it takes a mirror of that DOM tree and keeps it in JavaScript objects. And with that mirror, i.e. a snapshot, the virtual DOM, what it's able to do is it's able to manage how updates flow into the real DOM and essentially acts, maybe buffer is not a good word, but acts as a middleman so that when you work and build React components, you don't make changes directly into the DOM. You'll make changes into the virtual DOM or a snapshot of the virtual DOM. React will figure out what things need to be changed. It will overlay that on the virtual DOM and say, this is the current state, this is the new state that I want in my DOM. And then it will just apply just the changes that it needs to, and it can batch changes together. So the main reason why this is performant is if you're familiar with how a web browser works, there are 3 major phases to showing any kind of update or even the first time you show a web page. So what that looks like is something like this. There's actually 14 distinct phases, but there are 3 major phases. The first one is the browser has to parse the markup and the CSS before it can show it, i.e. it has to create a render tree from the parsed markup and CSS. And once it's gone and created the render tree from the HTML and CSS that you provide the browser, right? Whether it's the first time you load a web page or if you're building a single page application and you go and attach something into the DOM, it still has to do the same thing. The final step is the reflow and repaint. So we parse the markup in CSS. We go and create a render tree that essentially looks like, the browser goes and creates a render tree that essentially looks like the HTML elements that you want to show. And then finally it applies those and actually paints them onto the web browser window. Right? So 3 major steps: parse markup in CSS, render tree, reflow, and repaint. And out of those 3 steps, the one that's usually the slowest is actually doing a reflow and repaint. Because of the way that HTML is a flow-based layout, right? So when you add elements to an HTML page, you don't get absolute positioning. As you add elements, if you put an H1 and then you have a div underneath that which has a pre or whatever inside of it, all the stuff in the web browser flows from the top left to the bottom right, right? It's a flow-based kind of flow-based view model. So that's where the reflow happens, i.e. it has to figure out exactly where all the elements need to be positioned based on the HTML and CSS that you provided it. And then it has to actually take that, once it's figured out the exact location of all those elements that you have on your web page, and then it has to go and apply that and do a repaint to essentially show it to the user. Okay? So again, when we talk about the things that can do this, what triggers a reflow and repaint? Anytime you update a DOM object, if you hide a DOM node, if you go and move or animate a DOM, if you make a style change in CSS, right? Any of those things will trigger a reflow and repaint, i.e. these are the things that you want to avoid doing so that the user doesn't see sluggishness in your single-page web application. All right? And so that is essentially where the virtual DOM comes in. What the virtual DOM does is it manages the state of the DOM. It acts as a buffer or a layer in between you, the programmer, and the web browser. So when you build and work with React components, those changes that you create inside of your web application, those will actually get copied onto a snapshot of the virtual DOM. React manages all of this for you, so you don't have to do anything. So just explaining the concepts here, you don't actually have to do any of these low-level things. As you'll see in just a second, what you have to do is just create React components and weave them together and let the framework handle everything else, managing the virtual DOM and other things like that. Right? But it's important to understand what's going on here, because one of the key concepts around this is with React.js, you never ever go and actually manipulate the DOM directly yourself. You always use a React component to do that. In fact, they do have a way where you can go and monkey with the actual DOM directly if you want. And I think that function the function is called something like change DOM state dangerously. Okay? So that's, they actually codified it into the function itself. If you so happen to want to go and change the DOM yourself, they have it named appropriately and basically don't do this. And so the DOM is managed by a virtual DOM. And once we have this snapshot and we apply changes using React components, the virtual DOM and the React implementation underneath it does a smart diff. So you may actually go in your elements and change a bunch of different things. But maybe only 3 changes need to be applied because most of the changes are already inside of the DOM itself. So it'll just take 3 changes we need to apply to a snapshot of the DOM, and then essentially materialize that in the real DOM. So we go from our snapshot of the virtual DOM to the virtual DOM itself, and that gets pushed down onto the DOM itself at that point. Okay? And again, as a React developer, you don't really need to do any of this stuff programmatically. These are just some high-level concepts so you kind of understand what's going on here when you're working with React. Right? You have to make sure that you follow the appropriate rules, and having a good understanding of what's going on here is obviously very helpful. Okay? The other thing, again, if you remember just a second ago, it's the reflows and repaints, which are usually the most expensive part of doing some kind of update in the web browser in your single-page web application. And again, what the DOM does, aside from detecting that you only need to make these n number of changes, it will also say, well, you've changed the state of your application, right? You went and you filled in a search, the user filled in a search box, and now we're going to populate a search box window or search box panel with search results. It will actually just go apply all those changes all at once so that you don't trigger multiple reflows and repaints. Okay? So this is the reason why you look at benchmarks comparing React.js to other frameworks. This is the primary reason why it's so much faster than almost every web framework that's out there. Right? And these are both synthetic performance tests and real-world tests that folks have done. If you do a Google search, you'll find a bunch of these results, and it's actually quite impressive. The number of frames per second and just raw updates that you can do with React is mind-bogglingly fast. All right. So we've talked about some of the concepts. Let's talk about some of the basics for a few minutes. Right? We'll actually code up some components, and we'll see how all this comes together in just a second. So the basic thing in a React application are React components. Right? It is a component-based framework. And it uses a specific syntax known as JSX, or JavaScript XML syntax, where the markup, i.e. something that looks like markup, the JSX, is actually embedded directly inside of your JavaScript file. Right? And there's some people who immediately look at that and say, that's way too much like PHP or something for me, right? This is just crazy. Right? But you have the option of using JSX, or you can code everything in just JavaScript if you want. Because again, what React does is it's mirroring the entire DOM. So within the React framework itself, you have access to all of the different DOM elements that you would normally have access to if you were just writing HTML. Right? We'll see that in just a second when we get into some code. Right? JavaScript XML syntax, and if we look at a quick example of this, this is JavaScript, by the way. You can see that what we do if we embed this directly inside of a browser widget is, let me see if this thing is working. Yeah, if you embed this directly inside of a browser widget, you see that we use a specific script tag to let the React engine know that this is a bit of JSX that it needs to run transformation against. But you can see what we're doing here is we're saying React.renderComponent, and then here's an H1 tag, or what appears to be an H1 tag, blah, 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 blah. And then this document.getElementById is basically the second argument that we're passing in here is this is where we want to mount this component into the DOM. Okay? Again, we'll get into a little bit more code and dive a little deeper so you get a better idea. But just a few more words on JSX. It is HTML-like, but it does differ a little bit from HTML. So for example, if you go to this URL, one of the things that you have to be aware of is that when you're typically creating an HTML element like this H1, or say you have a div, or whatever it may be, there's a lot of times you want to give it a class, right? You want us to go and point this specific markup and say this is the style that it should have. So instead of using the keyword class, because class is a keyword in ES6, and they future-proof this a little bit, what you do is instead of saying H1 class equals class whatever, you would say H1 class name with the capital N equals the class that you wish to assign to that specific div element or that specific HTML element. Okay? So there are little nuances like that, but it honestly doesn't get in the way that much in terms of being able to go from thinking in HTML and then thinking in components with React, and using the same kind of DOM elements inside of both. All right. So talked about JSX, right? But if you don't want to do that, you can also use the React objects that are inside of the React library. So here we're saying react.dom.h1, here's our hello world, and then the second argument there in the render component is where we want to mount that component. But you can see that this is plain JavaScript at this point. Okay? So you have two options. You can either write JSX, which is what most people do, and the exact equivalent of what we just saw a second ago is this. Okay? React.dom.h1. Sorry, let me go back. Right, so that's the exact equivalent of what we wrote in the previous slide on JSX, or in JSX. All right. So what the render component does is that it says, okay, this is the component we want to mount somewhere inside of the DOM. And again, React manages your entire web browser, and you are supposed to do everything you need to do through React. And we only render component once inside of an application. You don't need to render components multiple times. What we typically do is we think of React components and a React application just like with the DOM. We start with the root component, and then from there the root component includes subcomponents which have subcomponents. So you start from the top, and you basically just say render the top level component into somewhere in an HTML template, and you go from there. Right? We'll look at this in code in just a second so you get a better idea of what this looks like. Right? All right, so again, when we want to bootstrap a React application into the browser, we say render component, and where we want to attach it to the DOM. You typically only do this once. You don't see people doing this a lot. All right? So in terms of custom components, this is where the rubber meets the road, as they say. We want to be able to create our own components so that we have a library of components that we weave together. And the way that you approach the initial development of a React-based web application is you essentially start with a conceptual model of the browser being your home or your app component, and then you add components underneath that. And it kind of forces you to think of every little part of your web page as some kind of component, whether it's a fine-grained small component or a large-grained component like a panel that includes a login form or something like that. Okay? So what we do is we create a class, and inside the render function, or inside the render property, we define what that class actually looks like. So we would do something like this. We would say, create a React class. In the render, return that specific component's stuff. Right? And so once we have that component, if you look at the top here, you can see we call this thing var my component equals all this stuff. Right? It's basically just a h1. Nothing too fancy so far. But when we're ready to use that, we would just say react.renderComponent, and you can see I'm using the JSX style syntax here, and I've closed the tag, told it where to mount it. Okay? So at this point, you might be wondering, okay, it looks like it's fairly easy to create components. How do you actually pass data into these components so that, you know, this is a dynamic, living, single-page web application we're building? How do you pass in components? How do you pass data into components? And how do you kind of weave the data and your components together? There are two things that we use to do this. First thing is called attributes. The other thing is called state. And we'll get into both of those in a few minutes. All right, if we look at an example again, I've tried to keep these examples simple. You can see instead of saying hello world, we'll this time say hello this.props.name. Okay? And well, how do we send that this.props.name data into our component? When we do a render component, here's my component again, and you can see I just stick it on as an attribute and say name equals my name in this case, and that will get propagated into this.props.name. Okay, so that's how you typically do an initial bootstrap of your data into your React web application. All right, so at this point, what I'd like to do is do a quick demo. And can you guys read that code? Is that big enough? Okay. Right, so what we're going to do is I have some plumbing set up, and I'll explain the plumbing in a few minutes, but I just want to write a couple of components to give you an idea and kind of the developer velocity, the speed that you get as you're building something, and conceptually how we would think of this. Right? So I have some plumbing running in the background. Let's go and make sure this is working. Right, I'll just change this to something else. I don't know. I'm just going to make this up. And hopefully this will update. Okay, it's updated our component. What I'm specifically using here is for the styling and everything, there's a very nice library called React Bootstrap, which essentially takes the Bootstrap UI library, and they've created native isn't the right word, but they've created React components from it. So it's a super nice library, especially if you already use Bootstrap. They also have one for Foundation that some folks have written. So there are a couple of these components, off-the-shelf component libraries that people have ported over to React, and people also have just components that are available that you can just plug into React as well. Right? You'll find a whole bunch of them on GitHub. All right, so let's start, and let's do something a little bit more elaborate. We have our current issues here, and let's say that first thing we want to do is we want to add a login panel. Okay, so let's go and create a login panel component. Here's our login panel, React.createClass. In my render property, div, panel, and you can see here's class name instead of class for that specific class that needs to be there. And again, this panel is a Bootstrap panel that I'm specifically using here. Okay? And then I say header, enter your login details, and then this has a subcomponent inside of it called login form. And that login form is actually in a separate JavaScript file. So the way we typically would organize a React-based application is we put all the components into different JavaScript files. Right? So currently I'm in home.js, as you can see here on the top left. Now I have this login panel just in my home.js, but I probably want to put it somewhere else. But I have my login form in a different location. So here's my login form. You can see we're using standard Node.js style requires to essentially organize our code. We go into login form, right? Login form, React.createClass, div, here's standard HTML input, type equals blah, type equals password. We have some default values, and then we have a button, login, et cetera, et cetera. Okay? So this is essentially our subcomponent for the actual login form, which we're going to use inside of our login panel right here. Okay, so we create a div, we create a Bootstrap panel, we include the login form into that. So now all that's left for us to do to show this is we need to add the login panel as a subcomponent into our main React class. Our main React class, again, is just called home, and that's the thing that we're doing a render component on and fixing all of our subcomponents. So I can come into here and say login panel and login panel. And once I save this, we should have a nice little login panel if I didn't break something. It helps if you write the script in the right way, I guess, right? Right? I may need to refresh this browser because I caused a hard crash. Let's see what happened. There we go. Okay? So we've added a login panel, and we've created this into subcomponents. We have a few other things that we can do here quickly, just to give you a taste of how we kind of work with different types of things, right? So let's say the user's already logged in. I'm not going to implement this feature right now, but what I am going to do is I'm going to use the React Bootstrap grid layout system, and I'm going to go and create just some issues or something like that, right? So here we have a grid that comes from React Bootstrap. We have a row, we have a column, and then we have this thing called issue panel. So let's go have a look at that issue panel real quick. Okay, our issue panel is right here. And you can see what we're doing here is, obviously we're going to need to show some issues. So let's actually save this code. Let me make sure this got added in okay. All right, so here's our issue panel. We're going to pass some data from this React component down into the issue panel, which will then get passed down into an issue component that represents all the different issues we have in our tracking system. All right, so let's change this real quick. Name that back to what it was. Here's our issue panel. Now, if we save this, we should get our issues here. And we have a couple of things going on here, which I'll explain quickly. So if we go into our issues panel, Here's our issues. You can see that the data that I've set up for these issues is just some mock data, just as we're kind of building through this. What are the things we need to have? All right, so we could change this, and let's change these issues to be something else, save them, and you'll see that the issues then have changed right here. Right? Hopefully you guys can see that okay. All right, so let's go have a look at our issues panel, which is inside of a Jumbotron, which is inside of a grid, and blah, 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 okay? But if we go look at our issues panel, you can see what first thing we do is we get some of the internal content ready. So what we're going to say is, again, here's the this.props.issues. If you remember the issues, that was the specific property we set or the attribute we set as the data that we wanted inside of the subcomponent. Okay? So now if we go into here, we do issues.map, right? Map is obviously a standard part of JavaScript now. And what we're going to do for each one of those is we're going to return a subcomponent called issue, and that will have the issue title that we had in our original data. So what this actually will create is it will create a panel that contains our content, which has a list of all the issues that we've created inside of our application, right? This is just some mock data I'm using. So if we look here closely, again, issues map for each one of the things that are in that issues object, return this little bit of React.js JSX markup, right? So it'll basically do a list of these things. So it'll look essentially like this. Okay, so if we go close this, right, we should have a fourth one that will just show up here. Okay, you get the idea, hopefully, of how this is constructed and how we're putting this together. All right, so we have our issue system kind of working here, and we have some issues. And when we go and actually look at the issue component, you can see that we're not actually doing anything crazy here. Again, we're using a bootstrap panel. Here's our label. Here's the this.props.name, right? Because this is the subcomponent that actually needs to show the title of that specific issue, right? So we just stuck that into a label, and essentially that's what gets rendered, or i.e. that is what the component is once it is all ready to go, right? So you can kind of see how the data flows from the top as we pass it in this guy right here. And so if I just add another bit of data to this, it'll pop up in just a second, right? So this is our little mock data that we're using as we're kind of prototyping this user interface that gets passed into the issue panel here. Issue panel picks it up from the this.props.issues. We iterate over them. We use the issue subcomponent, which is this guy right here, that gets plugged into some JSX. And then that essentially is a div. And inside of here, when somebody clicks on one of these issues, we've gone and wired it into a handler. So if we look at what this issue selected is, that's this function right here. So you can see that this create class has this arbitrary function that we can then use somewhere inside of the React that class itself. Right? So you can see that this issue is a React class. When this thing is clicked, this.issue selected. And what this is doing is it's basically just using a very simple dispatcher to go and tell a sibling component that, hey, someone selected something. So if I come into here and click on one of these guys, you'll see that something should change. There we go. So you can see that our issue, this issue was selected, is just changing over here, right? Nothing too crazy, but we're just using a dispatch model, something like an event emitter, to let a sibling component know that it needs to change in some way, right? And what this actually does, if we go look at the other part of the dispatcher, in this pay bounty panel or whatever here, we have in the component did mount, and we'll talk about get initial state, component did mount, component did unmount. These are the lifecycle properties that are associated with every React component. We'll talk about those in just a second, okay? But you can see what we do is when the component has mounted, i.e. React says, okay, I'm going to walk the tree, I'm going to build all the components, I'm going to put them into the web browser. Whenever any component gets mounted, its internal component did mount property is essentially, basically a callback. It fires. In this case, what we do is we say attach a dispatcher, essentially attach an event listener for issue selected, and when it fires, we call this issue callback. which in turn goes and does this.setState, issue selected, et cetera, et cetera. Okay, and we'll talk about state a little bit as well. State is probably the most important concept, aside from the virtual DOM, that you need to know to be successful at programming in React. Okay, so we've done a quick flyby of this, just to give you a taste of how all this is put together. Now, let's talk about the component lifecycle and the component specification, because we looked at those in code very quickly. There are a bunch of different things like get initial state, get default props, component did mount, component did unmount, component will mount, et cetera, et cetera. These are all things that you hook into as a developer so that you can essentially build your application, right? There's also this concept of mix-ins, so that you will often have components which are different components, but they may need to share the same kinds of these callbacks, right, or these essentially lifecycle methods. So you can use mix-ins to do something like this, and what this looks like is essentially looks like, you know, classic mix-in. You're doing things where you have cross-cutting concerns, and you just wish to share them between components so that you don't have to copy and paste code, right? So copying and pasting code is bad, as Venkat said in the last session. So you understand that what cross-cutting concerns are and the value of sharing code by using a mix-in. So the way that this would work, right, and we'll just do a really simple example and say we would create a JavaScript object called log mixin, and inside of that you can see here's that component did mount. This is a React lifecycle method, right? We're not in a React component here. This is just a standard JavaScript object literal. And then we'll say React.create class, and we can specify mixins, log mixin, comma, some other mixin, comma, some other mixin. So we can mix in multiple objects if we want. We pass in an array of the mixins that we want this component to have. Okay? So it's using standard JavaScript mixin type of technique to be able to share the different lifecycle functions if you want. Right? Some of the other things that we didn't kind of talk about much, right? We looked at the component did mount, i.e. fire this callback once the component is actually shown to the user. The component it will render, i.e. the component is about to be rendered, it's already been mounted but hasn't been rendered yet. And of course, in some situations when a component is destroyed and removed from the view, you may want to do some cleanup, so you can attach a callback function into component will unmount to go and do some cleanup or whatever it is that you'd like to do. Right? So these are just some of the lifecycle methods in a React class that you use to be able to build your application. All right, so the next big thing I want to talk about is state. This is probably the most important concept in React. Depending on who you ask, i.e., you know, if you talk to a bunch of React programmers, they'll say, oh, the virtual DOM is the most important thing, or this other thing is the most important thing. In my opinion, the way that you work with state and how state ties into the operation of building a web interface or a web application is the most important part of React. Components have state, and when we think about building something in React and we need to go do something, we don't think about, okay, we need to go and put something into the DOM here, or we need to go and attach some binding to this so we can kind of see what the user clicks on or whatever. The way we think about a React application is in terms of state. The user fills in something into a search box. They hit submit or search. The next thing we think is, okay, we need to change the state of the application so that the state now contains the search results. Obviously, we'll have like a search result component that will get populated, created, whatever. But we think of everything in terms of state. So we think in terms of components. Components have state. When we need to change something in the user interface, we think of changing the state. We don't actually think about, okay, hey, let's go change this component, or we need to change some markup over here to show these search results. What we do is we say, okay, we need to go and update the state to reflect the fact that the user wants search results. So we think in terms of state, and this is extremely important. Right? If we look at how state is implemented, and this is just a quick demo here, you should never actually do this where you do get initial state. You should always set the state from properties either from a parent or when you initially bootstrap the React application in the browser. Right? But just for the purpose of this demo to show you how this kind of works is we're just saying get initial state set to count to 5, and then within your React component in the render or anywhere, you can do this.state.count, and to get it, to actually go and set it, you would do what we showed before, which is In this case, you saw right here, we said this.setState, and then we passed in some data. And when we call a setState inside of a React component, it basically tells React that, hey, this component has changed in some way. The state of the component has changed. Let's go see what that change was. Obviously, you have to write the code for seeing what that state was. But let's go see what's changed, and let's reflect that change in this component and all of its subcomponents. So oftentimes, you can trigger a change way down into a subcomponent by passing in state from the very top, right? The kind of root or the home component, and let it filter all the way down. Or in this case, what we did is we actually set state all the way down here in the subcomponent. Okay? So you can do things both ways. And it might seem that, hey, this is kind of crazy. Why would I want to go and set the state at the very, very top and let it filter all the way down through the subcomponent, the subcomponent, the subcomponent, the subcomponent? It seems wasteful to have it traverse all the way from the top down. In reality, you don't really have to think about that too hard because React is so fast because it's working with JavaScript objects. It's able to go and basically run down that tree and push that state down very quickly. So even if you have a moderately complex React-based web application, you don't have to worry too much about it, to be honest with you, right? In some places, we do it where it makes sense. If we need to make large changes and those changes are across multiple components, we'll just set the state here at the top and let it filter down to those two sibling components or sibling subcomponents. But in this case, we're just using a dispatcher, so we just say, all right, whenever we see this specific event emitted, let's go and just set the state inside of the specific component. We don't really need to bother all the other components with this new state, okay? Right. The other thing is that in this specific example, we did a onClick. Right, when this thing is clicked, go and run this JavaScript method, okay, or function. So the other thing, aside from wrapping the DOM, React also needs the ability to be able to wrap events. So React actually has synthetic events that it wraps native events with. Again, as a developer, you don't really worry about this too much. There are just a couple of small rules you have to follow. But essentially, it's a cross-browser wrapper around the event system in the web browser. Because if you remember from one of the first things we discussed was that React is essentially a layer that sits between you, the developer, and the web browser. You never reach directly into the DOM to do stuff. Similarly with events, you let React's basic cross-browser component wrapper that has synthetic events, that wrap native events, essentially do some of the work for you, okay? All right, so if we look at another example of setState, you can see from our previous slide, we have setState up here, and this is how it would initially get reflected somewhere inside of our application, right? This is similar to the example we showed, except in this case, we're just setting the state for the count to be something or whatever. Okay? So when we did this onClick inside of our code, this onClick essentially, it becomes a wrapped event that gets redirected into our React application, and that's how we essentially trap that specific event and then do something with it. Okay, we're just saying when this button is clicked, go and run this.increment count, which went set the state, very similar to the example I showed live here in just a second ago. All right, so changing the state causes a refresh, and that's how you basically change something in React. You go and you say this.setState somewhere, like we saw a second ago, to go and change our application in some way, right? The user clicks something, or the user wants to log in now, so they filled out some form, or you want to go and do an autocomplete inside of a text field, or whatever it may be. You basically listen for those events. When those events come in, you go and set the state at the appropriate level and the appropriate place in your application, and your web application becomes updated. All right, so let's look at another slightly complex example to give you a better idea of how kind of all this stuff comes together. Right, just make sure we have enough time for this. Right, so I'm going to open up a separate project here real quick. All right, this is kind of small, but that's okay. Actually, before we get into that, let's explain some of the plumbing that's actually going on here. And let's look at how we kind of bootstrap, right? Because I just jumped directly into the components instead of actually talking about how we get all this going. So in this specific project, we're using some fancy things. We're using 6-to-5, right, or Babel, so that we can write an ES6 style. We're also using Webpack underneath the hood, so we can just require everything using standard node modules, and it will convert them into the appropriate thing when it gets shipped up to the browser. We have a few other things that we're using here. But here's our home component right here, component/home. Right, so if we go look and see where that home component is used, right, you can see we create a factory from this home component. And then on the server side, we do React render to string. This is where the isomorphic part of this comes in. So what this will do is this will basically go and render the component on the server for us. And then you can see what we do with that rendered content. Right, so if we were to print this out, we would actually see basically all these things that we have in our React application here, starting from the top level home component. We have content, right, that gets pushed into content, and then we essentially take that and we merge it into an HTML template and send that back to the browser, right? So that's basically, here's our content. We're saying the data.body, we're just using a simple template. So if we go look at the actual template itself, not really much going on here. Right, so just, again, this is just for the bootstrap part of this application, right? Once React takes over with components, we don't really worry about this too much. Simple HTML file here. We're including the bootstrap CSS, right, because we're using React Bootstrap. But here's the body, and you can see this looks like a little template syntax here, which indeed it is. This is body. So if we go into, back to server.js, you can see what we do is we go get the template, set the title and a few other things. We set the body to be content. We merge that into the template, and then we send that back to the browser, and that essentially is what bootstraps our application. We also have something else, obviously, that we need to bootstrap, and that's our script source, right? Because we're using essentially a module builder here called Webpack that goes and grabs all of our files and essentially does a little bit of a build process to bring everything together. And the other thing that we're using here, as you probably noticed as I was typing this, is that I never actually had to go and do a restart of the server or anything like that. That's because, right, so if you remember, as I was working with this, where's our main component, right? Right, if you remember, all I had to do was type and save. That magic was happening because I'm using Webpack underneath the hood, which is constantly listening for changes that I make, and does a rebuild every time I change something. So that's what I'm running in the background here. Whenever I change something, it would go and compile everything, get it ready, and essentially do a push into the browser using something called browser sync. So again, it makes for extreme rapid development when we're doing this. Okay? I don't want to get too much into that because it's going to take us onto a long discussion of Webpack and how browser sync works and other things like that. But you can go get a bunch of React.js starter projects which have all this stuff set up for you, so you don't have to set it up yourself. You can just start using these cool things like Webpack and browser sync and other things without actually having to do all the configuration yourself. Okay? But this is our module loader. It's going and grabbing a bunch of stuff and shipping it up to the browser inside of the template that we showed a second ago, right? Which is script source, which is what our server.js was producing. I mean, what do we set the script source to? Let's have a look. Right. So you can see specifically if it's in development, it sets it to this. If it's in production, it just builds a different file. Right. Anyways, all this stuff is set up, so we don't want to go too much into this. But that's how we do our initial creation. But if we look at a slightly more complex example real quick. Okay. This is a Twitter stream example. So my top level component in this case is the, we're calling it tweets app in this case. And you can see that we have a bunch of code here, but let's go to the render method or render function. You can see here's get initial state, component did mount. We're doing lots of different things in here. But if we look at the main render function, what we're doing is we're setting up some grids inside of here, right? So this is essentially just like a conference wall type application where it just shows tweets and other things like that. But what we're interested in here is how does the data flow through this, right? So let's go look at the get initial. Right, so here's our original tweet data. We're going to go and grab some data that it passes in initially inside of here. So let's go and look. Right, so here's where we are grabbing the state of all the tweets we want to show on this specific wall. And then if we go into the tweets component, this is essentially just using a what's called a list group inside of Bootstrap. But again, you can see we pass that tweets from the main component or the root component down into the subcomponent. We're doing a map again to create this list of subtweets, and this is obviously not a HTML component, it's a React component that we created. So if we go into tweet.React.js, you'll see that inside of here we go and grab the various things that are passed down as properties into our specific application, right? So just a quick flyby of another application, kind of show you how everything is grouped. It's very similar to the one we previously demoed. Right, this is a slightly more complex application in terms of layouts and other things like that. But the main idea here is that we have different components. In this case, these components are all in separate files. And again, we're using ES6 and a module builder to bring everything together to ship it to the browser. But once this goes live, React takes over in the browser, and it does a live update by streaming tweets over socket.io, right? This specific example is available on my GitHub account if you'd like to look at it in more detail. But what I'd like to spend the last few minutes doing is talking a little bit more about the architecture and giving you an idea of kind of, well, we kind of already talked through some of these different things already. We're creating the class. We're mapping the tweets into sub-components. We go and push the state down from the top. So we set the state at the top. We translate that into properties that we push down into subcomponents. Okay? That's how you basically pass data from the top to the bottom, is by pushing properties. So you set the state somewhere, and then when you need to push some of that data that's in that state to a subcomponent, you set properties. Okay, we looked at very quickly how we're doing the isomorphic part just a minute ago. When we go and we do render component to string, that essentially does a server-side render and prepares the initial bootstrap of the application, or just serving up all the components as pre-rendered HTML rather than rendering them in the browser itself. Okay, so again, we generate an initial page on the server, new data is rendered in the browser, right? We can do this with render to string for a specific component, or for every component, or whatever we want to do. We can slice this however we want. We can have React run completely in the browser and not do render to string on the server and just say, okay, here's my React application, just go run everything in the browser, or we can do a mix and match of that if we want. All right, so I want to spend a few minutes talking about, I'm going to skip over all this stuff. All right, so we already talked about set state, invoking render for components and all subcomponents, right? Again, we would think that would be slow, but again, remember, we have the virtual DOM that makes React extremely fast in terms of performance in the real world when we need to do updates into the DOM. Right? We talked about how the virtual DOM does smart diffing and can do batch DOM updates. That's where it gets its speed and power from. Right? And on the server, let's skip past all this stuff actually. Talk a little bit about animations, right? So one thing is, when we need to do animations inside of React, we don't want to directly monkey with the CSS or HTML at any point in time. So what we have to do is we have to be extremely careful about how we do animations and other things like that, right? So in this case, what we're going to do is we're going to say, let me go to the right place. There are specific things inside of React. Specifically, there's this thing called a React transition group, which allows us to encapsulate an animation in a specific place that we want that to be. So in this case, we've just called the animation or the transition name as example. So then if we go and look at our actual CSS for this, right, it was called example, so it was poorly named. But again, what we did is we wrapped our area or our thing or our component that needed to have some animation. We wrapped that in a React transition group. In this case, that is the React.addons.css transition group. You can also do, obviously, div-based animations, but in this case, we're doing CSS-based animation. And if we go look at the style for that, again, the transition name is called example. If we go look at the style for that, okay, you can see here's the example. What it does is it looks for that transition name -enter, -enter active, -leave, -leave active, right? And you can see what we're doing here. Not too crazy. We're basically applying a transform to say translate it to 100%, i.e. move it off the screen. When it's active, set the opacity to 1, and basically have it fade in and come in from the right. Okay? All right. So in the last few minutes, what I wanted to spend time talking about was the kind of architecture around this. So React, one of the chief complaints about React is that it's just the view layer. You don't get anything else. You don't get a model. You don't get a view. How do you do routing inside your application? You know, there are lots and lots of little things that you need to do to be able to build a successful single-page web application, right? So there are some libraries, like there's something called React Router, which is really nice. It allows you, in a React style, to be able to build out routes, essentially, inside of your single-page web application, your React single-page web app, and gives you nice-looking routes in the URI and things like that. It's called React Router, and there are a couple of implementations, but there's one that most people are using today for doing stuff like this, right? But the main thing I want to spend the last few minutes talking about is one-way data flow, right? In React, we don't really have this concept of two-way data binding like we do in Angular and other frameworks, right? And what this diagram is, this is a diagram of what's known as the Flux architecture. This is the suggested architecture from the React folks in terms of how do we build a nice, organized React application that has all the stuff we need to be successful to build something, okay? So if you look at the way that these arrows run, you can see that there's no two-way. This is not a two-way street. This is only a one-way street. The idea is that you only flow everything in one direction. Remember earlier I said that the way that we make a change in a React application is by setting the state, right? Everything flows from that, or maybe flow is not a good word, but everything kind of springs from that, right? So what we do in a React application is, especially if we're using Flux specifically, they break things down into these three major areas: actions, dispatchers, stores, and views. Right? So the stores will allow us to share and have some local data inside of our application. There's a dispatcher which allows us to do event emitters between subcomponents if we need to do that. And then we kind of have a concept of actions. When the user has the view up, i.e. React is rendered and is shown to the user, and the user clicks something, we come to the top, we hit an action, and we kind of flow down. So the user interacts with our app, we go to the top, we flow downwards, okay? And obviously in the action, we may need to make a server-side call to go get some data or whatever, but that's fine. We go and we grab some data, action goes and says, okay, this is what we're going to do with the data, and we flow downwards from there, okay? So the Flux architecture is just that. It's just an architecture. It is not. They do not provide an implementation out of the box for it. This is basically, they say this is how you're supposed to build React applications. Now there are some implementations of the Flux architecture. There's Reflux, Fluxery, and a few others. But what I would suggest to you is, if you're new to React, you probably want to avoid doing those things, at least when you start, because if you want to be successful, trying to do all that, learn React, learn the Flux architecture, it's quite complex once you add Flux into it. React itself is great because it's extremely simple. That's what I like about it, right? There's not a lot of different things you have to remember in your head to be successful at building a React-based application. You can just keep a few concepts in your head, component lifecycles, setting the state, et cetera, and that's it. Right? Just a few things you have to keep in your brain to be able to build a nice React application. If you add in Flux with the dispatcher and the stores and the event emitters and all this stuff, it becomes quite large in terms of having to figure out, hey, how do I build something with this? And what is this thing over here used for? Am I using the store in the right way, right? It opens up a lot of questions. So if you're new to React, what you want to do instead is you just want to just use React. Prototype something out, and then you get an idea of the simplicity of just looking at the web world through components. It makes a huge difference to be able to take something, put it together very quickly, especially with some of the tools that I showed in terms of the automated browser sync and other things like that. You get really rapid development, but you're also keeping your code base extremely simple because you're conceptualizing everything as components and state. Okay? So have a look at Flux and those other things, but when you start off, just use, just at this point in time, you should probably just use React, and maybe if you need some of these other things, right, once your app gets more complex, maybe you want to sprinkle them in, okay? And in my opinion is that the Flux architecture is great. When I build my own stuff, I model my own workflow inside of a Flux application using this Flux architecture, but I think it's too much I don't think it's gotten to a point where it's really mature yet. The Flux architecture stuff is relatively new. React has been around for a while. Flux stuff is relatively new, and it's kind of a moving target. So it's something that I'm avoiding at this point in time until someone comes out with a simplified implementation of this architecture that will allow me to build a React application without getting in the way all the time. Okay? All right, and with that, we talked about Flux already, so we'll skip that. And with that, there's some references here that you can go, and there's some great articles on scotch.io on React that will help you get started, and they actually do the Twitter example on there as well. So are we taking questions here, or do we? I can't remember if we do that here or not. Such a big room, so. Where's our room monitor at? Okay. Well, if you have any questions, come find me at lunch. I'd be happy to answer them for you. Thanks for coming to this session.